Hello, grade 12 calculus students. I've put together another video to help you guys prepare for the upcoming derivatives chapter test. So the questions that you'll see in this video, they'll be very similar to your real tests. So make sure you understand how to do all these questions. And some of these questions are quite long, so if you know how to do the question, you may want to pause the video, try the question on your own, and then check your answer with my answer at the very end. So you don't have to sit here and watch the entire video. Just go right ahead and work at your own pace. Okay, so one of the questions that you will see on your chapter test is that I will ask you to find the derivative of a trig function. So in question number 1, I'll ask you to find the derivative of f of x equals to sine x using the definition of the derivative. Now, in order to do a question like this, I'm going to give you guys a few identities that you will have to use throughout the problem. So one identity that I give you is this double angle identity. Sine of x plus h equals to sine x cos h plus cos x sine h. Now, you don't need to have a great understanding of trig functions in order to do this problem, but you need to be able to use your algebra skills in order to solve this problem. Okay, so if you don't understand trig functions or you haven't seen enough trig functions, don't worry. I think this question is more designed to test your algebraic skills instead of knowing how to use trig functions at the highest level. And a few other identities I give you in this problem is this limit identity right here, which I believe this came up in one of the in-class assignments. So these two trig identities are things that we have seen in the in-class assignments, and I just want you to be able, and for this problem, you just need to use these identities when you get stuck. All right, so let's just go ahead and start the problem, and as I'm working through the problem, you'll see where I can use these identities. Okay, so step number 1 here, it's probably best to write out the definition of the derivative. So this is the limit as h goes to 0 of f of x plus h minus f of x all divided by h. Okay, so that's step number 1. Write the definition of the derivative. Step number 2 is you want to substitute your function into the definition of the derivative. And the function that we're focusing on here is f of x equals to sine x. Alright, so let's go ahead and substitute sine x into the definition of derivative here. So this is the limit as h goes to 0, and this will be sine of x plus h minus sine x all divided by h. Okay, so there it is. There's the proper substitution step. Now, in order for you to continue this problem, you need to use the identities that were given to you at the start of this problem. So right here, I'm going to highlight this part right here. This is sine of x plus h. Hopefully you can see that that matches this identity right here. So what you want to do next is you want to use a substitution step again. So let's go ahead and substitute this identity here. So this is the limit as h goes to 0. And once I use the substitution step, this would be sine x times cos h plus cos x times sine h. Okay. And then I'm going to subtract the minus sine x, and that's simply just this part right here, all divided by h. Okay, all right, so I've correctly used this identity right here, and after that I probably won't have to use this identity again. So let's just continue and finish off the rest of the problem here. Now, what I'm going to do next is I'm going to highlight this sine x cos h and this negative sine x, and I'm just going to rearrange the terms in the numerator here. So I'm going to rewrite this as sine x cos h minus the sine x plus cos x sine h all divided by h. Okay, so that step right there, I'm just rearranging the terms. So that's just an algebra step right there. And then you'll notice that I have a sine x there and a sine x there, so I'm going to factor that sine x out. So this is going to be sine x, and if you factor that out, you're going to get a cos h minus a 1 plus everything else on the numerator, all divided by h. And don't forget your limit sign as h goes to 0. Okay, so the next step that I'm going to apply here is I need to use the limit properties, and when you have a limit sign right here in the front, you can actually distribute that to everything inside. You can distribute that to everything on the right-hand side. So I'm going to distribute that over here, and of course over there. So if I distribute this limit property, I'm just going to do this. I'm going to rewrite this as the limit as h goes to 0 of sine x times the limit as h goes to 0 of cos h minus 1. Now I still need to consider this h on the denominator there. So what I'm going to do here is I'll put the h right below the cos h minus 1. And the reason why I did that is because if I put the h on that cos x minus 1 term, if I highlight this guy right here, you'll notice that it matches one of my identities right here. Okay, so I want to use this identity eventually. So if I put the h on this term right here, then I can use one of my trig identities. Okay, and then if I continue to distribute the limit sign, then I'll have the limit as h goes to 0 of cos x, and this cos x right here is this cos x right there, and then I'm going to multiply that by the limit as h goes to 0 of sine x, or sorry, of sine h, and this h right here is that guy right there. And for this guy, I will put the h over here. So remember, this h has to be accounted for as well. So I'll put the h over there. And the reason why I've put the h on that term, and I mean, you could also put the h on this term, but you'll realize that putting the h over there won't help at all. And if I put the h on this limit term right here, you'll notice that I can once again use one of my identities that's given to me in this problem here. Okay, so let's go ahead and just finish off this problem now. This is the limit as h goes to 0 of sine x. And this whole limit right here that I'm highlighting here in yellow, well, that's just going to be 0, so times by 0 plus, this is the limit of h goes to 0 of cos x times, well, this limit here that I'm highlighting in blue right there, if I go back up to my limit identities here, that's this guy right here, and that's simply going to equal to 1. So I will just put a times 1 there. And once we evaluate this, this whole thing goes to 0, and this expression right here is simply going to be the limit as h goes to 0 of cos x. Now notice that I have an h here and I have an x there. Okay, so the variables don't match. If the variables don't match, you can't take the limit, and your final answer is basically what your expression is. So that's going to be cos x. Okay, so the answer to this question is cos x. So if I say what's the derivative of f prime of, sorry, if I give you, so the question was, given that f of x equals to sine x, f prime of x will equal to cos x, which is the answer that I got right in here. And if you go back to your in-class assignments, the one in-class assignment where I asked you to graph the trig functions, this is indeed the right answer. You get the same answer from the in-class assignment. It's just that this time we're actually doing it algebraically instead of graphing the functions. All right, so that's how you do that question, and you will see a very similar question on your real test where you do have to take the derivative of a trig function, and I'll probably give you at least 3 identities, and your job is to use those identities and simplify the problem. Okay, great. Let's move on to the next question on your practice test. All right, I'm going to decrease the size of this. Okay, so question number 2, use the graph below to answer true or false. If false, explain why. Okay, so let's go ahead and take a look here. Question number 1, true or false. F prime of 4.5 is greater than 0. So basically this is saying that the slope at x equals to 4.5 is positive. Okay, so let's take a look at where 4.5 is. Well, here is 4 and here's 5, so 4.5 is probably going to be 1, 2, 3, 4. Okay, it's probably going to be somewhere over here, 4.5. And if I go straight up, and here's my point right there, is that slope, if I draw a tangent line right here, is that tangent line positive? And it is positive, so this answer will be true. So the slope at x equals to 4.5 is positive. That is true. All right, the next part, true or false. F of x is differentiable at x equals to 2. Okay, so where is x equals to 2? Well, it's right here. All right, so are you differentiable at that point? And the answer is false. And it's false because, well, you have a hole there, and so it's not continuous. It's not continuous, and the limit does not exist. All right, so the limit doesn't exist if it's not continuous and you're not differentiable. Okay, good. Part 3 now. F prime of 1 is greater than f of 4. Okay, so f prime of 1, this is basically saying the slope at x equals to 1. So what's the slope at x equals to 1? Well, if I look at my graph here, here's x equals to 1, and if I go straight up, you'll notice that I'll have a horizontal tangent line. So the slope here has to equal to 0. All right, so if I go back to my question here, let me just delete this. If I ask you what f prime of 1 is, that's going to be 0 because the slope is 0. Now, is 0 greater than f of 4? Well, let me just kind of erase everything over here. Where is f of 4? Well, here's 4 right here, and at f of 4, what's the height at f of 4? Well, the height at f of 4 is going to be 0. So, is 0 greater than 0? No, this is false. Okay, so basically you would say here that to finish off this question, you would say f prime of 1 is equal to f of 4. All right, it's not greater than f of 4, but it's equal to f of 4 because both have values of 0. All right, the next part, true or false. F of x is continuous at x equals to 3. All right, going back to my graph here, here is x equals to 3. I'll just delete all this. Okay, so here is x equals to 3, and if I go straight up, are you continuous at that point? Well, the left-hand limit and the right-hand limit, they equal each other, so yes, this will be true. And for the last question, true or false, the limit as x approaches 3 exists. Okay, so since my left-hand limit and my right-hand limit are equal to each other, yes, this would also be true. All right, so there you go. So on your real test, I'll give you another graph, and I'll ask you very similar questions. And if a statement is false, you just need to explain why. All right, so that takes care of that question. Let's move on to the next one here. And for this next question, I'm going to blow this question back up. So zoom in. Now, for this next question, I need to find the values of a and b so that my function f of x will be differentiable everywhere. Now, we haven't seen a question like this in class or the homework yet, but you know, we definitely have the knowledge to approach a question like this. Now, let me just kind of draw you a little picture here to kind of show you like what's going on in one of these kind of problems. If I draw a function here, a random function. Now, in order for this function to be differentiable everywhere, well, first of all, this function has to be continuous. Is it continuous? Are there any gaps? Well, this function here that I've kind of drawn, that I have here as an example here, it is continuous. There are no holes, there are no gaps, and basically you need to show that for this kind of question, you need to show that your function is continuous, and that your left-hand derivative has to equal to your right-hand derivative. So if you can show those characteristics, then that's how you would approach a problem like this. Okay, so let me just kind of delete this. All right, so let's kind of go ahead and start this problem off. So step number 1 is I want to show that we are continuous. Continuous. All right, so if I want to show something if I want to show that a function is continuous, you could show that the left-hand limit equals to the right-hand limit. And for part 2 for this question, another way to show that you are differentiable everywhere, you need to show that your left-hand derivative must equal to your right-hand derivative. Okay, so if the slopes are equal on both sides of your point, then you know, you are continuous and you are differentiable because the slopes are equal. Okay, and another way to write this is the limit as x approaches some value from the left-hand side of f prime of x, that must equal to your limit as x approaches that same value from the right-hand side of your derivative. All right, so if you can show those two things, 1 and 2, then you've pretty much solved this problem. Now, this kind of question will require a little bit of algebra here, so just be prepared and try to avoid the simple mistakes if you can. Okay, so let's go ahead and use step number 1 here. I need to show that the left-hand limit equals the right-hand limit. Okay, so let's set up a limit statement here. So this is the limit as x approaches. Now I'm approaching the value of 4 here, so I'm going to go ahead and write down 4 here from the left-hand side. And if I'm approaching the function from the left-hand side of 4, that would mean I'm working with this equation first. So that would be 4 root x. And that will have to equal to the limit as x approaches 4 from the right-hand side. And that's going to be this guy right here, which is going to be ax squared minus bx. Okay, so this is another way of showing that the left-hand limit must equal to the right-hand limit. All right, so since f of x is a polynomial, since f of x is f of x isn't a rational equation here, so in order to evaluate these limit statements right here, all you have to do is you can just substitute this 4 right into your equation. So this would be 4 times this 4. So I'm just going to do a direct substitution step right there. And I'll do the same thing on the right hand side. So I'm going to substitute this 4 into there and there. So this will be a times 4 squared minus b times 4. Okay. Now I want to highlight the 4's here. Now I know some students may say that you could use the number line technique where some people might say, why can't you do 3.999 repeating, and over here you could do maybe 4.000 repeating 1. It's true that when we had these one-sided limit problems in the previous chapter, I did use you know, these kind of values when we were doing these one-sided limits, but you need to recognize in this problem that 3.999 repeating is basically the same thing as 4. And 4.0000 repeating 1, that's the same thing as 4 as well. So in order to simplify this problem, you can go ahead and just use the integer values. You don't have to use these values over here. In fact, basically, if you are given a rational equation, if I give you something like 4 over x minus 4, you know, this is a function where you have a vertical asymptote, then you want to go ahead and use these kind of values like 3.9999. But in this question, since we have no vertical asymptotes, we can go ahead and just use the integer values. Okay, so let's go ahead and do this. This is going to be 4 times 2, which is going to be 8. This is going to be 16a minus 4b. So 16a minus 4b. So once you've done that, that's equation number 1 here. Okay, so that's part 1. We've done the left-hand limit equals the right-hand limit. I've done that correctly there. Now let's go ahead and do part 2, where I need to show that the left-hand derivative equals to the right-hand derivative. Okay, so this will be the limit. Let me write my limit statements again. So this is the limit as x approaches, well, the value of a in this case, once again, that's going to be 4. So this is 4 from the left of f prime of x. Now let's evaluate this f prime of x here. So if I'm approaching 4 from the left hand side, I'm dealing with 4 root x. So if I have 4 root x, this is the same thing as 4x to the power 1/2, and if I take its derivative, then it's going to be 4 times 1/2 x to the power negative 1/2, which is going to be, well, this right here is going to be 2, so this would be 2 divided by the square root of x. Okay, so I'm just going to delete all this now and put this in here now. This will be 2 divided by the square root of x, equals to the limit as x approaches 4 from the right hand side. And if I'm approaching x from the right hand side, sorry, 4 from the right hand side, I'm working with this parabola right here, ax squared minus bx. So if I have ax squared minus bx, if I take the derivative of that, that's going to be, sorry, that's going to be 2ax minus b. All right, so that statement right there shows you that my left-hand derivative equals to my right-hand derivative. And once again, we can just do a direct substitution here. So I'm going to highlight these 4's. And whenever you see an x there, just substitute the x's with the 4. So this will be 2 divided by the square root of 4 equals to 2a times 4 minus b. Simplify this. This will be 1. 2 divided by the square root of 4 is 1 equals to 8a minus b. And this is your second equation here. All right, so you have 2 unknowns and 2 equations here, so you can just set this up over here as 1 equals to 8a minus b. Okay, so the final step for this problem is you just need to solve this system of equations right here. And there's several ways you can do a question like this. You can take equation number 2 and you can multiply that by 2. So if I do that, this will be 2. This would be this would be 16a, and this would be negative 2b. And if you subtract these 2 equations, if you take 1 minus 2 now, 8 minus 2, that would give you 6. 16a minus 16a is 0. Negative 4b minus negative 2b would be, well, it's going to be negative 2b. And in this case, sorry, I think I made a mistake here. This is going to be no, sorry, actually there are no mistakes. This would be 6 equals to negative 2b, and b would equal to negative 3. Okay, so b equals to negative 3 there. Sorry, I was just thinking about that problem there. I thought I made a mistake, but I didn't see any mistakes. So let's just go ahead and finish off the rest of the problem here. So b equals to negative 3. And then once you have b equals negative 3, you can substitute that back into one of your equations. So I will use this equation over here. This is 8a minus negative 3. This is 1 equals to 8a plus 3. And if you solve this, a should equal to negative 1/4. Okay. All right, so there are your values. A equals to negative 1/4 and b equals to negative 3. All right, so sorry about the mistakes for that problem, but those are indeed your final answers there. Okay, yeah, sorry, I'm making this video pretty late in the night, and if I make a mistake, I do apologize. It's pretty hard making these videos when you're tired. All right, question number 4 here. All right, now we have some easy questions now. Differentiate the following. Do not simplify your answer. So that's key. Do not simplify your answer. So let's go right ahead and approach these problems here. For the first question, I have a 10 here, an exponent there, so you might be thinking we need to use the power rule. And eventually, once we use the power rule, we probably would have to use the chain rule too. So using the power rule, I get 10 times x plus 1 to the power of 9. And if I apply the chain rule here, x plus 1, the derivative of x plus 1 is just going to be 1. And you can leave your final answer as just 10 times x plus 1 to the power of 9. Good. Moving on now. Y equals to 4 times the square root of x plus 1 over x all to the power of 5. Alright, let's approach this problem right here. So what I'm going to do first is I'm going to rewrite everything in terms of a power here. So this will be x to the power of 1/2 plus x to the power of negative 1 all to the power of 5. Okay. Alright, so let's go ahead and take the derivative here. So this will be y prime. Okay, so let's go ahead and use the power rule here. So if I bring down the 5, that's going to be 4 times 5 bracket x to the power of 1/2 plus x to the power of negative 1, close the bracket. And using the power rule, that will give me a value of 4 on my exponent. And then I take the derivative of the inside guy here, and that's going to be 1/2 x to the power of negative 1/2 negative x to the power of negative 2, close the bracket. and that's it. I will take that for full marks. I mean, if you want to simplify this 4 times 5 and just leave that as a 20, you could do that as well, but you don't have to do that. I will give you full marks for just using the chain rule and the power rule there. Okay, let's move on. Next question, f of x equals to x divided by x plus 1 all to the power of 3. Sorry. For this question, we just need to apply the quotient rule here. So let's go ahead and do that. Before we use the quotient rule, we got to use the power rule and the chain rule, and then we'll use the quotient rule. So if I use the power rule here, this is going to be 3 times x over x plus 1 all to the power 2. And then the chain rule tells us that we need to take the derivative of the inside function, and this is where we have to use quotient rule here. So in order to use the quotient rule, we would take the derivative of I believe we take the derivative of the numerator first. So that's going to be 1 times the bottom, which is x plus 1, minus the derivative of the denominator. So the derivative of the denominator is going to be 1 times the numerator, which is x, all over the denominator squared, x plus 1 squared, and yeah, that would be it. I would take that for full points. Okay, let's move on to the next question where we need to take the derivative. So for this question here, it's going to be I see a lot of square root signs, so it's probably going to be one of those chain rules where you have a chain rule inside a chain rule. And the very first thing I would do is I would write everything in terms of a power. So for a question like this, sometimes it's easier to start on the inside. So if I have the square root of 2x plus 1, that would be the same thing as 2x plus 1 all to the power of 1/2. And then I would just work my way out. So start from the inside and work your way to the outside. So after that, I have this 3x. So this is going to be 3x plus, and then I have this square root sign, so let's put everything to the power of 1/2 again. Alright, and then I have this x term there, so I'll have an x here with a plus, and that will be everything to the power of 1/2 in order to compensate for this whole square root sign. So that's going to be that guy right there. Okay, so I have a lot of these square root signs, so let's go ahead and find its derivative here. So you might want to write small here because this will take a fair bit of room here. So sorry, I have y there, so I'll write down y prime. Okay, so starting with this power right here, this 1/2 right there, I'm going to bring that to the front. So that's going to be 1/2 times x plus bracket 3x plus bracket 2x plus 1, close bracket to the power of 1/2 to the power of 1/2 to the power of sorry, I need another bracket to the power of negative 1/2. Alright, so that takes care of the first power. And then the chain rule tells us that I need to take the derivative of this inside guy now. Okay, so if I take the derivative of the inside guy, the first term, well, I need to take the derivative of this x term, so that's going to be 1 plus, all right, and then I need to take the derivative of, you know, this. Sorry, I need to take the derivative of, yeah, this 1/2 term right here. So if I put that 1/2 in front, it's going to be 1/2 times 3x plus 2x plus 1 to the power of 1/2, all to the power of negative 1/2. Okay, so let me just highlight this part in green here. That takes care of, you know, this power right there. And then finally, the chain rule states that I need to take the derivative of this inside part now. And this inside part's not too bad, but I don't have enough room here, but I'm just going to shift over here. So this will be, if I take the derivative of, you know, my 3 here, this is going to be, sorry, the derivative of 3x is 3 plus, and then I need to take the derivative of this 1/2, So that's going to be 1/2 in the front. Bracket 2x plus 1 to the power of -1/2. Alright, so that's the power rule right there. And then finally, I need to take the derivative of this inside function, which is going to be, that's going to be the easy part, which is going to be 2. Close bracket, and then I will close the bracket off there. Okay, so there it is. It's a pretty long answer here, but I will take this entire thing as a final answer there. Okay, so you might want to try this question a few times because you do need to focus on the powers there and make sure you have all the powers in the right place. Okay, let's move on to the next question here. Question number 5. Consider the limit expression. The limit is, actually I made a mistake here. This should be h. The limit as h goes to 0 of x plus h all to the power 4 minus x to the power 4 divided by h. So you know, this might look very similar to the definition of the derivative. So in order to do this problem, I'm just going to write down the definition of the derivative first, because eventually we want to find the tangent line and the normal line. But let me go ahead and write down the definition of the derivative, which we saw back in question number 1 again. And what you have to recognize is that this is f of x right here. This part highlighted in yellow there. That's f of x. Alright, so if you match that up with the original question here, that would correspond with this part right there. Okay, so if you pay attention to the definition of the derivative, for this question you should see that your function is just x to the power of 4. Okay, so when I give you this fancy definition of the derivative here, just by looking at that, hopefully you can recognize that the function is given to you, but maybe not directly, but you need to recognize that the function is f of x equals x to the power 4. Now I want to find the tangent line and the normal line. If I want to find the tangent line, I need to use this equation, y minus y1 equals to m onto x minus x1. And I'm interested at the point x equals to 2. So if I substitute that into my tangent line, this would be m times x minus 2. And we need to find the value of y1. So in order to find the value of y1, I can just substitute f of 2 into my original question here. So this would be 2 to the power of 4, which is going to be 16. So this will be y minus 16. So that's just bringing that value over there. And then for my tangent line, I need to find the value of m here, and that's simply finding the derivative when x equals to 2. So I'm going to delete all this. Alright, so let's find my derivative here. So this is f prime of x, which is going to be 4x cubed. And I want to find the slope when x equals to 2. So this would be 4 times 2 bracket cubed, which is the same thing as 4 times 8, which is 32. So my tangent line is going to be y minus 16 equals to 32 times x minus 2. Now if you want to find your normal line, you just need to flip the slope here you need to have the opposite reciprocal here. So this would be -1 over 32 times x minus 2. And there it is. Here's my equation of my tangent line. This is the equation of my normal line, and that would give you full points there. Alright, let's move on. The next question. If f of x equals to this big polynomial, find the third derivative when x equals to -1. Alright, so this is a higher order derivative question. So you want to find the first derivative, then the second derivative, and then the third derivative, and then you want to evaluate that at x equals to -1. Alright, so what's f prime of x? This is going to be 12x cubed plus 18x squared minus 6x plus 7. That's the first derivative. And then we want to find the second derivative. This is going to be 36x squared plus 36x minus 6. And then finally we want to find the third derivative. And that's going to be 72x plus 36. and then we need to find, we need to evaluate the third derivative at x equals to -1. So here we just substitute the -1 into any value of x that we see, and then you want to compute this in your head here. This would be -72 plus 36, and that's going to be -36. So there's your final answer there. Alright, and on your real test, I'll have one question where I give you the graph of f of x, which is this guy right here. So this is your graph of f of x, and then I want you to find its derivative, or graph its derivative. Okay, so how can we approach this problem here? Well, this part right here, the graph, that part highlighted in blue, what you can, that's not too hard to graph. If you want to graph its derivative, that's not too bad, because if you look at that blue line, the slope of this blue line is +1. All right, it's a 1-to-1. Okay, so what that means is for all your negative values right here, if you want to graph the derivative, you just need to give me a value of +1 here. So just deleting all this again. So this right here has a slope equal to 1, and that's why I have the derivative value of a horizontal line with a value of 1 there. So that's how you graph the derivative of that line right there. Now for the second part, you have this half circle thing. Let's delete this. And the very first thing I like to do is I like to find the horizontal tangent line. So you have a horizontal tangent line right there. So when x equals to 2, your derivative has a value of 0. So here's a 0 right here on my derivative. This is f prime of x. Okay, and then what you should do next is you want to evaluate the slopes on the left-hand side and the right-hand side. If I look at the right-hand side here, you know, my tangent lines, notice that my tangent lines, they are increasing. All right, they're getting very big. So basically I would have to say that basically what's happening is the slope is increasing. It's increasing on the right hand side. So just show me something that's increasing. So this is increasing right here. Okay, so that takes care of the right hand side. I'm just graphing the slopes right there. So since the slope is increasing, the derivative has to have a relationship where you are increasing. Okay, and since the slope over here, the slope here is positive, so you should be above the x-axis, and my derivative there is above the x-axis. All right, so in order to kind of finish off this problem here, maybe all you have to do next is you want to evaluate the graph of f of x on the left-hand side of that of the minimum point right here. And over here, first my slope is 0, and then it's becoming then it's negative over here. Then it's becoming more negative and more negative and more negative. So the slope is decreasing here at a faster rate, and since the slope here is negative, you should be below the x-axis. So you want to graph a relationship where you're below the x-axis like that, and your slope is getting bigger and bigger and bigger. So this right here would be an acceptable answer for graphing the derivative right here. So this right here is below the x-axis. And that's simply because the slope over here is all negative. All right, so if your slope is negative, your derivative should be below the x-axis. Okay, let's move on to the last few problems here. This is the last problem that I will go over for this video here, and that should conclude you know, this video tutorial here. And once again, I do apologize if I'm going a bit too fast. I didn't want to take too much of everyone's time here today. So I recommend just using these problems and see if you can get the answers again, and just use the video as a key maybe. Alright, so for the last question here, I give you a function where I have y's and x's. Now, in order to do a problem like this, you need to recall that if you're taking the derivative of a y variable, the derivative of y is dy by dx. Okay, so for one of these questions where you have to find the derivative implicitly, you have to remember that the derivative of y is dy by dx. Alright, so the very first question is find dy by dx. So that's the same thing as find the derivative of this function here. And I want to note that whenever you have an expression like this, x times y, that's the same thing as, you know, f of x times g of x. So you have to apply the product rule when you're dealing with the x and y term right there. All right, so you got to think of the product rule right there. So like f prime of x times g of x plus g prime of x times f of x. All right, so you definitely have to use the product rule when you're working with a question like this. Okay, so let's go right ahead. The derivative of y, or the derivative of y to the power 2, that's going to be 2y. And then using the chain rule, I need to find the derivative of this y term here, so that's going to be dy by dx. Minus, all right, so as stated, I need to use the product rule here. So let's take the derivative of x first. The derivative of x is just 1, so this will be minus y. And then I want to take the derivative of y next, so I'll have a minus x, and the derivative of y is dy by dx equals 2, and the derivative of 5 is just going to be, that's 0. Okay. The next thing that you could do is you could rearrange your terms to get the dy's all together. So this is 2y dy by dx minus x times dy by dx. And I'm going to take this negative y term and I'm going to bring that to the other side. So that's going to give you a value of y on the right hand side. And then I'm going to factor out my dy by dx terms. So this is dy by dx of 2y minus x equals to y. And then finally just solve for dy by dx. And you want to divide the right hand side by 2y minus x. So this 2y minus 2x is this 2y minus 2x term right there. And there it is. There is your first derivative, dy over dx equals to y divided by 2y minus x. Part B. Part B is asking you to find the second derivative, and you should evaluate this at the point 1, 2. Okay, so if I know that my first derivative here from part A is y over 2y minus x, I need to find the second derivative now. So this is going to be d squared y over dx squared. And for a question like this, since I have a fractional expression here, I have a numerator and a denominator, this means I need to use the quotient rule. Alright, so the quotient rule is basically saying that you need to take the derivative of the numerator first. So if my numerator is y, the derivative of y is dy by dx. And then I times that by the denominator, which is 2y minus x. And then I need a minus sign for the quotient rule. And then the quotient rule states that I need to find the derivative of the denominator. So the derivative of 2y minus x, well, the derivative of 2y is 2 times dy by dx. And the derivative of this minus x term here, that's going to be minus 1. So let me put this in brackets here. And then I need to multiply by the numerator, which is y, all divided by the denominator squared. Okay, all right, so there's my second derivative there. Now, in order to kind of finish off this problem here, whenever you see the dy's by dx terms, you need to substitute that with the original answer from part A. So let me just go ahead and do the substitution step here. So dy by dx is the same thing as y divided by 2y minus x. And this is going to be bracket 2y minus x minus 2 times dy by dx. So this will be y divided by 2y minus x minus 1. And I'll put this all in a bracket here. Times by y. And I will divide this whole expression by 2y minus x all squared. Okay. Alright, so I think that looks right so far. And then the question states that I need to evaluate this at the point 1, 2. So what I'd recommend now is you need to evaluate this at the point 1, 2. And the best way to kind of finish off this problem is to just do a direct substitution. Don't try to simplify anything. Leave your second derivative the way that it is and just substitute the numbers here. Okay, so I'm going to just do this step over above here. So if I have a y there, I know the value of y is going to be 2. So this will be 2 divided by 2y minus x. If I look at this 2y minus x term, if I plug in the value of 2 into this expression, that's going to be 4 minus 1, which is going to be 3. So we can just do that in your head, 2/3. And then if I put in my numbers in for this expression right here, 2 times y minus x, that's going to be 4 minus 1, and that's going to be 3. So you can probably do those calculations in your head. Then I have my bracket here with my 2, and then another bracket here. This expression right here, the y is going to be a 2 there, and the denominator is going to be 4 minus 1, which is going to be 3. Minus 1 times y, which is 2, all divided by okay, so if I plug in the point 1, 2 on my denominator there, I get what? 4 minus 1, which is 3. 3 squared is 9. Okay, so I have a 9 on my denominator there. So let me go ahead and see if this is right. Hold on, did I do my second derivative correctly here? Hold on. Alright, so I looked at the numbers, and I think the numbers are substituted correctly here. And let's just go ahead and just finish off the rest of this calculation, I guess. If I focus on this part right here, that's going to be 2, because the 3's just cancel off. And then if I focus on this part right here, this is going to be minus, okay, so 2 times 2, that's going to give me a value of 4 over 3, minus the 1, bracket times 2, all over 9. Okay, so sorry, that's a bit messy, but I think we're on the right steps here. So if I continue to evaluate this, this will be 2 minus 4/3 minus 1 is going to be 1/3 times 2 divided by 9. This is going to be 2 minus 2/3 over 9. And if you do the math here and work this out, you get 4 over 27. Okay, so 4 over 27 should be your final answer for that problem there. Okay, let's move on to the final question here. Find the coordinates of the horizontal tangent line. Now for this question, you need to have your first derivative. So your first derivative from part A is dy by dx equals to y divided by 2y minus x. And your original question was y squared minus xy equals to 5. Okay, so we need to find the coordinates of the horizontal tangent line. So the horizontal tangent line. Now, if we're finding the horizontal tangent line, you may recall that for these kind of problems, you need to take your derivative, and you need to take your derivative and set it equal to 0. Okay, so once we've taken our first derivative, you want to take your derivative and set that equal to 0. That will give you the horizontal tangent line. And for a problem like this, whenever you have a fraction equaling to 0, you have to remember that a fraction is equal to 0 when the numerator is equal to 0. So here's my numerator, which is just y. So if I set my numerator equal to 0, I just get y equals to 0. Okay, that's great. So the question is, I want to find the coordinates of the horizontal tangent line. So I know my y value. My y value is going to be y equals to 0. Now I just need to find my x value. And how do you find your x value? Well, you take your y equals to 0 and you plug it back into your original function. So this would be 0 squared minus x times 0 equals to 5. And you'll get 0 equals to 5. Alright, so this is a weird expression here, 0 equals to 5. So since 0 does not equal to 5, what this means is we can't find the x value. So what this means is we have no horizontal tangent line. Okay, so unfortunately for this problem, we did not get a horizontal tangent line because we end up with this conclusion over here, and so we just finish off by saying that there is no horizontal tangent line. Another good question that you should start thinking about is, I could ask you, find the coordinates of the vertical tangent line. So that's another good question that could appear on your real test. So if you're finding the vertical tangent line, you want to find some undefined points. So if I ask for the vertical tangent line, you would simply set your denominator equal to 0. So I don't have enough time to go over this question, but sorry, I'm just making all these mistakes here. But if you're looking for the vertical tangent line, you want to just take your derivative. You want to focus on your denominator here, and you would set your denominator equal to 0, and then go ahead and find your corresponding values. So that's a question that you might want to think about. And if you're not sure how to find the vertical tangent line, there is a question on your practice test in the textbook, so I recommend doing some of the problems in the textbook as well. And the last thing I want to kind of go over is this question right here. I'm not sure if I will put this question or a similar question on the test, but if you have enough time, if you want to think about this question, I'm not 100% sure if I'll put this question on the test or not, but if you have time, you might want to think about this problem. Alright, so that concludes this video tutorial. I do apologize. I feel like this video wasn't that good. But hopefully you can just use the questions and check your answers with the answers in this video key. If you have any other questions, please see me in class. All right, see you guys.